Good morning, everyone. In the previous video, we have discussed upon the operating system and what is operating system, how the operating system involved significantly with respect to the system and the application program, and how this particular uh, particular system structure being involved with respect to the OS and what is the operating system exactly is about. Okay, now we are going to discuss about the same definition of the operating system with respect to the resource controller and the control program. And first, with respect to the resource controller, the operating system will able to manage all the resource which has been utilized in the system architecture. And also with respect to the management of the resource, it will able to decide how it can able to conflict with the request of the resource effectively, and it should be fair enough to use all the resource which has been involved in the OS easily. Okay, then with respect to the control program, the resource which has been effectively utilized should be controlled while executing the program, and it should prevent all the errors and avoid improper usage of the computer. Then these are all the definition with respect to some of the concepts which we have focused upon, but there is no exact definition what exactly this OS operating system is. Example, with respect to the vendor, all are defining this particular operating system with respect to their point of view. Okay, then as kernel is the base for the operating system, whenever they are taking up only a particular program which is running all the time in the computer, which is nothing but the kernel. Okay, then we will be having the system program, which is the base chip of the particular operating system. Without the system program, the operating system cannot execute and activate or act with respect to the application program. Okay, and we have various application program which has been executed in the with respect to the application. Then we have computer startup, which is nothing but the bootstrap program, which is loaded whenever you are powering up or rebooting the system. Okay, whatever data you are managing, everything will be stored in the ROM and the EPROM. Okay, ROM, which is nothing but read only memory, and electrically programmed read only memory. Okay, these two are nothing but the firmware. First, we have to initialize the aspect of the system, and we have to load the kernel, which is start, and it will be running from the starting to the ending of the operating system, and it will make the particular execution to kickstart. Then we have a particular organization of the computer system. Okay, in the particular computer system, we have various CPUs which has been involved in the particular system operations. Initially, whenever you are going for the system computer, we have only one CPU that has been involved in executing and controlling the various aspects with respect to the OS. But as days goes on, as a development in the technology, we have multiple CPUs that have been involved in executing these operations in the particular system. For connecting all these multiple CPUs, we have a device controller that will connect to the various common bus to access and share the memory and to execute the operation. Then we have a major concept which is nothing but the concurrent execution, nothing but the Parallelly, we can execute multiple operations with various CPUs and the devices which has been involved in the memory cycle. And this is the best example for the system architecture. Nothing but we have a common bus that will connect with the memory as a shared one with CPU, disk controller, USB controller, and the graphic adapter. For the CPU, we have various multiple CPUs that has been connected with the system organization. Then the disk controller, we will be having a various disk structures which helps to manage the particular data which has been stored in the database, and also we will be having the USB controller where we will be having mouse, keypad, and the printer which has been involved in controlling the USB. Then we have a graphic adapter that has been, which is nothing but the monitor. Then we have a operations that will be involved inside the particular computer system. The IO devices on the CPU, while performing the operating system, we have IO devices, nothing but peripheral devices, which will take up the data, and the data which has been taken up, which will be put into the CPU, and the CPU will execute and manage and execute the particular data which has been involved in executing and managing the data concurrently. Then each and every device controller is in charge for a particular device type, nothing but the CPU, controller, and everything. Then for each and every device controller, we have a local buffer. The local buffer, whenever you are having a two or more data or the resource which has been added up into the device will control the data which has been, various data which has been involved in performing through this particular local buffer, which is nothing but the first in and first out, nothing but a stack operation. Then the CPU will move the particular data to main memory to the local buffer. The local buffer will take up this particular data which is from the device to the controller. The controller will inform the CPU that it has finished its operations without having any interruption. But whenever you are having two or more multiple data which has been involved in performing through this device controller into the CPU, they may cause some interrupts, like it cannot make the particular operation to perform within the stipulated amount of time. Then we will be having a common functions which has been involved while discussing about this particular interrupts. Interrupts will transfer the control to the interrupt service routine. Okay, what the service routine is about, they will be having a particular interrupt vector that will contain all the address of all the service routines. So it will take and it will push down the particular data into the service routine one by one, and it will get addressed in various fashion of first come first serve, last in first out, or some other fashions. Through this, we can able to avoid this particular interrupt. The interrupt architecture will save the address of the interrupted instruction, which is nothing but the finished instruction, and also the instruction which are going to come for the execution. Then we have a trap and the exception, which is nothing but the whenever there is a error or the request which has not been happened while the data is put into this particular service routine, which is nothing but trap or the exception. Then we have an interrupt driven. Interrupt driven is how we can able to overcome this particular interrupt which has been occurred into this particular operating system. Then we have an interrupt handler. How we can able to handle this particular interrupt occurrence. The operating system will preserve the state of the CPU by storing the particular data on the operations into the register and the program counter. What this register is about? Register will store the data while the particular system is performing the particular data. So each and every CPU will have microprocessor, microcontroller. As microprocessor, microcontroller will have n number of register which has been involved in storing the particular data which is involved in the particular CPU. And program counter is nothing but the which is the increment counter or the increment register will makes the particular data to execute one by one. Then we have various types of interrupt that has been involved in determining pooling and the vector interrupt system. Pooling is nothing but the we will be selecting and assigning various execution of the data or the interrupt types to determine and calculate the data manageability. And vectorization is nothing but the magnitude and the direction where in which sequence or the order this particular system has to be performed in order to avoid this particular interrupt. Then we have a system segmentation of code that has been involved to determine the action taken to avoid or mitigate this particular interrupt with various types, nothing but polling or the vector. Then we have an interrupt timeline. The interrupt timeline has been categorized with respect to the IO devices and the CPU. With respect to the CPU and the IO devices, we have a timeline with respect to user process execution, IO interrupt process, idle transfer. So first, the user process execution will take up the IO request and that will make the transfer done, and after making the transfer done, it will go while transferring the data. It may or may not have the particular interrupt process that will be handled, and it will go for the next way of execution. Then during this particular IO devices, first initially it will be in an idle state, then it will go for the transfer date. During the transfer state, before it ends up, it will go for this particular interrupt process. Like that, it will continue for each and every resource request. Then we have a IO structure. After making the initialization or the startup of this particular IO devices, we have a controlled resource to program the users only upon the IO completion. Then during this particular IO completion, it should take the particular instruction to wait in an ideal state until the CPU will go for the next interrupt. Before that, all the data should be in an ideal state, because if you see in this figure, first initially it will be in ideal state until the particular CPU will go for the next interrupt. Then we have to wait for the loop, nothing but how many data will able to access or contaminated into this particular system or the operating system. It has to go for the loop based execution, and also for each and every data to be accessed, it has to wait for the loop turn execution. Then we have a IO device request which is outstanding at a particular time, and no simultaneous IO process which has been involved at the same time, because whenever you are having a n number of data, the data has to be requested one by one by making the waiting time for all the process not to be simultaneously executed at the same time. After IO devices startups, the control will return to the user program without waiting for the IO completion. For the user program to return, we have a system call on the device status table. System call, which is nothing but the request to the OS to allow the users to wait for IO completion. Until then, the system call own initiate for the other data to get executed. Then we have a status table, nothing but it will indicate the type, address and the state